Okay, so let's do an application. I have here 8 cards. As you can see, I have 2 6s, 2 7s, 2 8s, and 2 9s, all scrambled together. Okay, so we're going to perform each of our shuffles today, and if you were here, I'd have you tell me which one would you like me to do first, so I'll just have to kind of randomly choose one. So maybe we'll do 34 first. So that's an alternate Klondike. This is where you stack, you deal out into a left pile and then a right pile by way of the Klondike shuffle. And for shuffle 34, we're stacking the right on top of the left. Very good. Maybe you'll ask for shuffle 36 next, let's say. So this is a judicious Klondike. So here we're Klondike shuffling pairs into 4 piles, and the stacking in shuffle 36 is from right to left. Okay, very, very good. And let's see, why don't we do the alternate Klondike, 33, shuffle 33. This is where we deal left, right, but this time we stack left on top of right. Okay, and the last shuffle we haven't done yet is shuffle 35, which is where we deal pairs to the table into 4 separate piles, like so, using the Klondike shuffle. And here we're stacking from left to right. Now rest assured that if you were here, we could perform these 4 shuffles in any quantity and in any order. In fact, we can perform any of the shuffles that we have shown you in this series as many times as you like and in any order that you would like. That's the amazing thing. Okay, so what I'm going to do here is just mix the cards further. If you think about it, we've been mixing cards into piles of 2 and 4. Well, maybe we should go ahead and deal out the cards into 3 piles, which is what I've done here. Okay, so this will just further scramble the cards. And now what I want you to do is I'm going to deal the cards into 4 piles again, but in the shape of a square, which kind of is fun. So where would you like this one? Top right corner, directly below, and this one up above, and then this one. What about this one? Want it over here, up there, over there, and then over here. Okay, tell me how you'd like these stacked. This one first, okay. Which one next? Bottom right, bottom left, and then top right. Okay, very good. Now I want you to feel comfortable with all of the mixing here, so what I'd like you to do is just cut the cards wherever you would like. That way I could not possibly know where you're going to cut the cards. So maybe you cut the cards right there, and we put the bottom on top. That's a cut. Okay, now from here we're going to just deal into 2 piles, and I have off to the side a prediction I wrote that's been in plain sight the whole time. So what is the prediction here? The 6s hate the 7s, and the 8s can't stand the 9s. What does that mean? Well, we've put them into 2 groups here, 2 piles of 4 cards. This is claiming that no pile should have both a 6 and 7 in it, and no pile should have both an 8 and 9. Ooh, is that even possible? Let's check this out here. What about this pile? There's a 6. Ooh, these better not be 7s here. 8, okay, that's fine. Oh, 6 is fine with 6. Oh, yes. Okay, so it looks like, yes, indeed, the 6s and 7s stayed away from each other. What about the 8s and 9s? Did they stay away from each other? They did indeed. These 2 groups just separated like oil and water. I think there's some truth to these statements here. I don't think the 6s like the 7s. Nor do I think the 8s like the 9s, and we have just shown it. Isn't that amazing? That prediction was written before all of the randomization choices were made, and it was shown to be true. Wow, how is that even possible? Okay, well, let's take a look at how that is even possible. Okay, well, there's so many ways that you can kind of set this up if you would like. An easy way to go is go ahead and, just stick with the two sets that we have. Remember our prediction. We don't want the 6s and 7s together in any way. We don't want the 8s and 9s together in any way, okay? So if you set up these disjoint little piles here and have as your plan, this will be one pile at the end and this will be a second pile at the end, then our prediction will come true, okay? So what we're going to do is I'm going to take either of these sets of 4 and then just set them on top of each other, okay? Now, this is pre-performance setup, okay? So you would, create those 2 blocks of 4 where you're wanting those blocks of 4 revealed in the end. Now, we already know a very clever technique from taking this organizational structure where you have the top 4 you want to keep together and the bottom 4 you want to keep together. If you do this triangle deal, do you remember that? This is Warner Miller's genius idea. If you perform this clockwise triangle deal and then pick up the first pile first, but now stack in counterclockwise direction, it will convert what we just had to a Bessey sequence. Okay, a Bessey sequence. Okay, so how do we see that? Well, it gets a little tricky to see. That's why I suggest that you use Warner Miller's little technique for converting it. But if you think about it as like a 1, 0, 0, 1, 0, 1, 1, 0, where are the ones? And are they safe to put together? Well, let's say this is a 1 here. So 1, 0, 0, 1. So we have a 7 and a 7 as a 1. Now remember, it's then 0, 1, 1, 0. So we would see that the 7s here would be paired with the 9s. And putting the 7s with the 9s is safe to do. It's the 6s and 7s that don't get along. It's the 8s and 9s that don't get along. Okay, so the remaining cards that could be represented by zeros would be the 8 and 6, and then over here the 6 and the 8. And those are safe to put together. So if you just take a few moments and study that structure, you'll realize that this is a Bessey sequence relative to those 2 disjoint sets of values. Okay? Now, once it's a Bessey sequence, we know that it's invariant or unharmed by any of the shuffles that we've shown you thus far, and in particular, the 4 shuffles we demonstrated today. So you can go ahead and perform any of these shuffles. Why don't we just do 2 of them? Why don't we do 33? But you can perform any of these, in fact, any of the 36 shuffles. See, shuffle 33, we're stacking left on right. Okay, and then why don't we do one of the judicious Klondikes? What about 36? So this is where you put out pairs into 4 piles, like so. And now the stacking for shuffle 36 is from right to left. Okay, so we'll just do 2 of them, but this is still a Bessey sequence. Okay, now, as an extra credit note here, performing 33 and 36, have we inverted this? Has it technically become, instead of 1, 0, 0, 1, 0, 1, 1, 0, is it now 0, 1, 1, 0, 1, 0, 0, 1? Well, look, it has, because shuffle 33 inverts the sequence, whereas shuffle 36 does not. So this has been inverted once. Of course, if we were to invert it twice, you get back to the original sequence form. But whether this is inverted or not will not undermine the conclusion in any way. Okay, so we have a Bessey sequence here. Okay, now if you remember, what I did next is I actually did that triangle deal. I kind of justified it and said, well, we've been dealing into 2 piles and 4 piles. Poor number 3 is feeling left out. So why don't we deal into 3 piles? Well, that's all a guise, really, because what I'm needing to do is use Warner Miller's clever little procedure for converting this back to a packet structure where the top 4 are of the kind that we want in one pile. You can see that. Remember, the 6 and 7s don't like each other, and the 8s and 9s don't, okay? And then here the other half is 7s and 9s. Those are safe. They don't mind each other, okay? So performing Warner-Miller's triangle deal on this kind of structure, which is what we had at the beginning, converts it to a Bessey sequence. And then if you perform that same triangle deal a second time, it converts it back from a Bessey sequence to this kind of arrangement, okay? And then from there, I claimed that I was going to perform a square deal. It sounds kind of fun. We just did a triangle deal. Why don't we do a square deal? So this is where I had the spectator, and these are free choices. I had them tell me like where to put these. We're going to create a square shape. Okay, very good. Where would you like this one? It truly is a free choice, which is amazing. This could go there, this one could go there, and there. And then look at this. You can pick these up in any order. It won't hurt anything. Okay, and we talked about why you can do that in an earlier video in this series. So you may want to make note of that. But we can actually pick these up in any order. And let me just tell you what structure we have now. I guess I can show that. It's not too hard to see. This is going to be an cyclic construction. It's going to alternate these two sets of cards. Now remember, the 6s and 8s are okay together, and the 7s and 9s. So what's going to happen is these will alternate relative to set membership in the two sets where you have the 6s and 8s together and also the 7s and 9s together. So this is kind of like having red, black, red, black, red, black. It's an alternating cyclic construction. Okay, so when you have something like that, you can freely cut it without harming that organization. We could have actually performed a Charlier shuffle if we wanted. This is where it's top to bottom, bottom to top, top to bottom. I have a separate video on the Charlier shuffle that you may want to look up to learn this shuffle. It's really just equivalent to cutting the cards just once at some location, which is quite surprising and hard to believe actually, but it is the case. So here we have like a red, black, alternating structure. So from this point, all I need to do, if we're wanting like all the reds in one pile and the blacks in the other, is just alternately deal them because they are alternating in their membership among those two sets. And so at this point, your prediction's going to be true, where you could bring it out at this point and say, well, I wrote this prediction at the very beginning about the 6s and 7s not getting along, and also the 8s and 9s. Is that actually true? Well, let's see what these sets consist of. Well, the first, oh yeah, there you go. The first pile consists of 6s and 8s, staying away from the 7s. And then the second pile, we know that the 7s, we know that the 8s and 9s don't get along, and they're not found in the same set. So we've kept those two groups of cards that don't get along with each other separate from one another, just as in the original performance. So anyway, that's how you perform that application. And it's just one of countless ones that can be designed once you understand the underlying principles being taught regarding Bessey sequences and Bessey shuffle diagrams. So thank you for watching, and take a look at the next video in this series, which will be the 10th video. And we'll be finishing up this series in just a few more videos. And you'll have a very large list of shuffles that preserve or invert Bessey sequences.